Hello and welcome to Learn Electronics YouTube channel. Ohm's Law.
George Ohm found that, at a constant temperature, the electrical current flowing through a fixed linear resistance is directly proportional to the voltage applied across it, and also inversely proportional to the resistance. This relationship between the voltage, current and resistance forms the basis of Ohm's law, and is shown below. Any electrical device or component that obeys Ohm's law, that is, the current flowing through it is proportional to the voltage across it, such as resistors or cables, are said to be ohmic in nature, and devices that do not, such as transistors or diodes, are said to be non-ohmic devices.
Electrical power.
Electrical power P in a circuit is the rate at which energy is absorbed or produced within a circuit. A source of energy such as a voltage will produce or deliver power, while the connected load absorbs it. These are electrical power relations. If the calculated power is positive, plus P in value for any formula, the component absorbs the power that it is consuming or using power. But if the calculated power is negative, P in value, the component produces or generates power. In other words, it is a source of electrical power such as batteries and generators. Electrical components are given a power rating in watts that indicates the maximum rate at which the component converts the electrical power into other forms of energy such as heat, light or motion. We now know that the unit of power is the watt, but some electrical devices, such as electric motors, have a power rating in the old measurement of horsepower or HP. The relationship between horsepower and watts is given as power within an electrical circuit is only present when both voltage and current are present. For example, in an open circuit condition, voltage is present, but there is no current flow. I equals 0, 0. Therefore Vx0 is 0, so the power dissipated within the circuit must also be 0. Likewise, if we have a short circuit condition, current flow is present, but there is no voltage. V equals 0, therefore 0xI equals 0, so again the power dissipated within the circuit is 0.
Energy.
Electrical energy is the capacity to do work, and the unit of work or energy is the joule J. Electrical energy is the product of power multiplied by the length of time it was consumed. So if we know how much power, in watts, is being consumed and the time, in seconds, for which it is used, we can find the total energy used in watt-seconds. In other words, energy equals power x time and power equals voltage x current. Therefore electrical power is related to energy, and the unit given for electrical energy is the watt-seconds or joules. Electrical power can also be defined as the rate by which energy is transferred. Electrical power and energy triangle is shown below. 1 kilowatt-hour is the amount of electricity used by a device rated at 1000 watts in 1 hour, and is commonly called a unit of electricity. This is what is measured by the utility meter, and is what we as consumers purchase from our electricity suppliers when we receive our bills.